Oh, thank you, mate. Just park it in its normal place.
Okay.
And the engine's running a bit rough. Could you look at it?
I'll have a look at it. Right, here we go.
Yes, I'm building my own two-seater kit helicopter.
Oh, yes!
The object of the exercise is to put on the tail rotor. You've got to put it on your head, haven't you, eh? Did I say this was simple? Hello my aviation chums, welcome to A Chopper is Born. Yes, I'm building my own 115 mile an hour two-seater executive helicopter and it is coming along a treat. Now for those of you who think I just throw this show together, it's all planned and it's all on paper, and today there are basically 4 jobs to do. I'm going to be putting in all the control mechanisms for the helicopter. Basically helicopters have 4 controls. They have a cyclic, a collective, directional anti-torque controls and a throttle. We'll be doing that later on. But first, I'm going to be putting in this bit. It's very large and it's very expensive. It costs about £3,000, and if I stick it up this way you will see it's actually the bit that you attach the blades to. It's the main rotor shaft. But before you can put this in the helicopter, you need to fit one of these. Yes, you need your DIY ladders when you're doing this job because you need to be at the top of the airframe because this is where this bearing is going to sit. Now, it's a heavy bit of kit. If you drop it, you'll damage the powder coating. So take your jacket, just drop that down there. There's a little bit of protection. The bearing itself is very straightforward. It's housed within a plate here. It's a movable bearing, self-adjusting. If you look on the underside of it, you can see that the hole here is eccentric to the outside, and that's because there will be a locking ring on here that eventually will lock onto the shaft. And front top, like so. Right, that's sorted. Next job, the bottom bearing. This is the bottom bearing. It needs to sit about there. But of course it needs some bracketry, which is what I've got down here. This is the upper engine mount clevis, and it sits up like so. Then this here is the bearing plate itself, which will sit on the front like that. I'm just going to just drop in a couple of bolts, one there, just get the nuts. Just need to tighten them up. The bearing itself sits in the plate like so, and a little top cap, and now I can put the expensive bit in. All I need to do is just sit it on this bottom bearing. There she goes. But is it worth £3,000?
This is your main rotor shaft. This whole assembly is going to attach to the top of the airframe. The engine will drive the system from the bottom end, and your blades will rotate around these pins. We get our raw material either as, in this case, bar stock, where we do the machining to the finished part, or we will get raw castings. We do get all of our castings made special for us, and we do all the machining in-house. We start with a piece of 4130 steel, and it's ground, so it's exact to dimensions. We have the top hub, which is shrunk fit, and down at the other end, the stub shaft. We heat the outer shaft. We're going to freeze the stub shaft to shrink it, and then slam them together before the temperatures equalize, so we have a very tight grip. Here we have a number of other components. We have the cyclic cable casting, a hub plate, which is made from a flat aluminum plate, the thrust blocks, we have teeter blocks, counterbalance, we have a non-rotating and rotating squash plate, and then as we get over here we have our scissor clevises mounted on them. We have the slider ball mounted into the squash plate, and then all of this would be assembled onto the rotor shaft to end up with the final product. This is a very complex piece of equipment. We completely assemble, completely fabricate this rotor system because it is such a critical part for the flight of this ship.
Now, the acid test is whether or not the shaft is exactly at 90 degrees to the square section tubes. And that is perfect, and I know I've put an inclinometer on the other way, and I know it's vertical in the other plane. So that is a top job. Excellent. Now we can move on to the controls. First up, the cyclic. Putting the cyclic controls together is not too tricky. Most of it can be done on the bench. You start with your drawing, because that'll kind of refer to everything, all the parts you need to put together. It's all dual controls, this helicopter. So you've got two control sticks there. They attach into two cyclic clevises here, which will attach to this, which is the cyclic main shaft that goes across the helicopter, which connects these two together so they move in the same orientation. And it's then a load of nuts and bolts to put it together. And we start with the clevis. Just has a couple of nylon bushes, and then it slots over the cyclic shaft weldment. And there we go. Next job is to fit the dual lateral tube. They have these little rod ends that are threaded into either end, and they just screw in. Then flip over the weldment so that I can drop the bolts through. There we go, and there you got it. We have dual control. Now I can put it on the ship.
Forward flight, my cyclic is basically my steering control and airspeed. Forward cyclic tilts the helicopter nose down, pulls the helicopter forward, increasing airspeed. Okay, in forward flight, the cyclic controls the direction of your flight and your forward airspeed. By increasing forward cyclic, the nose of the helicopter will pitch down and you'll gain airspeed. By moving aft cyclic, the helicopter will tend to slow down. Turn at altitude, I would be putting in left or right cyclic inputs to bank the rotor disc, and the helicopter would bank through the turn following the rotor disc. In the hover, we're using the cyclic just to maintain ground control balance. The helicopter would tend to move in any direction I move the cyclic, so the whole idea is try to keep the disc level and counteract any directional move with opposite cyclic input to hold your stationary hover.
So the whole apparatus fits onto the airframe, and this should be now quite a tight fit. Now on final assembly, when this is all tightened up, there are three basic safety measures for this so it can't become undone. Firstly, the bolt itself will be Loctited in place. It'll then be wired through these holes, and then also the aluminium bush will be pop riveted to the frame as well. Two bits to put in finally. Bit 1, bit 2. And this just slots in to here. Right, so there we go. All dry fitted together. We've got forward movement, aft movement, and then dual controls. They're linked together laterally. The only thing to go on here still, obviously, to connect the controls here up to the top of the main rotor shaft are the control cables themselves. There'll be two that will come through and fix onto the frame here, which will be connected to the weldment there. And there'll also be two more cables that will fit onto this bracket here for the lateral movement like that. Excellent stuff. Imagine what this is going to be like when the machine guns are connected. Right, section 10, collective control. I've laid out all the bits. So I've got basically here, pilot's handle this side, a cross tube, passenger's dual control which will go on that side like so, a bit of gubbins at this end to connect it all together and make the dual controls, and this bit of kit is actually the throttle for the pilot. Right, so the first job is to start all the way down here and actually start fabricating the dual control for the throttle in this end. We're going to drop in these two bushes, one in there, then we need the transfer shaft, followed by the first of two B control arms, like that. The second one goes kind of at right angles to the first one. Nut washer on the back, it's gone through a treat. So there is one mechanism, and then that will hook up with the passenger's collective control and the throttle at the end of it later on. Next job, pilot side.
Collective control is controlling the height above the ground, my skid height, raising collective. The helicopter hovers at a higher altitude. Lowering collective, the helicopter descends. Typically in a hover, there's minimal throttle work. At altitude, when you're making large collective movements, you need to adjust the throttle to help maintain the RPM. What I'll do is we come around on final approach, I'll reduce collective, you'll see how we descend, then I'll raise collective, you'll see how we climb. There appears a straight level, so I reduce collective. You can actually feel the helicopter go down, and if you look at the vertical speed indicator, you can see it's indicating the descent. If I raise the collective, we level off. If I continue to raise it, you feel the helicopter actually climbing, and the vertical speed is indicating the climb.
Got to attach this, the throttle grip sleeve, onto this, the end plug, and that's just held in with a roll pin. It's pre-drilled at the moment, so it slots in there. A little roll pin in the top, and then gently give it a bit of a bash. There we go, sorted. And then the whole shaft fits down the length of the collective handle. Let me just slide that in one end. So it's a little bit stiff at the moment because it's still covered in its protective layers, and if I strip that off it'll rust very quickly, so just a little bit of a squeeze down for now. That's sorted out, which put another one of these B control arms. There we go, and then it's just the bolt through and the nut on the other side. So that's the B control arm on. Now I need to put on this bit, number 8, E15 9030, the throttle connector, and yes, you guessed it, because it's got some welding on, it's a weldment. Right, to the ship. One of the things that I love about this project is that it's very modular. You build something on the bench and you then fix it to the airframe. Mind you, not saying it'll last like that, because once I've got a few more bits on it, it'll probably get a lot more complicated. So that's on there like that. And then finally, it's not going to go on now, but finally there will be the passenger's collective handle will go on, which means either the passenger not that I'll ever have one because people don't like coming flying with me for some reason, we'll be able to do the throttle there and also the collective, and the same from the pilot's side. Now you may be wondering why there's this odd sickle-shaped bit of metal at this end, and that's because at full throttle, which is round here, it acts as a stop by hitting the shaft. If that wasn't there, there's a possibility that this could go over further and actually go back under here, which means when you then try and dethrottle, actually you're pushing it the wrong way and it's jammed on full throttle. So it's just a safety, very simple but very effective safety device. So some cables to attach to this obviously, which will go to the engine, to the throttle, but that's sorted. So we've done the cyclic, done the throttles, done the collective. Now there was one more control. Yes, direction, anti-torque, that'll be the pedals.
The foot pedals are used to control the direction the helicopter is pointed. By applying pressures to the pedals, I can turn the helicopter left or right. Right pedal pressure, helicopter you rotate right. Left pressure, helicopter you rotate to the left. By dancing between the pressures and referencing an object in front of you, you're able to hold a straight position. In forward flight, they're just used to adjust for the amount of engine torque you're pulling out of the engine with the collective and throttle.
Now what I've done is laid out, as per the manual, all the bits in order, going from one side of the aircraft to the other, and each pedal is made up of a cast shaft like this. Now I have to get these the right way round because this is going to be the pilot's left foot, and this is slightly eccentric to make it more comfortable for the pilot, and that goes to the outside. So this will slot through here like so, and number 2 that goes in like so. 3 and 4 go here. So if we put that on first, pedal 2 there, my next spacer, then pedal 1, last spacer, that's pedal 3, next spacer, and last pedal. The pushes in there, with a bit of a squeeze, it will go in, but I'm not going to put that in yet because I've got to make some scissors. Yes, you heard me right, some scissors. These are a couple of scissors, not like the kind of scissors you cut things with, but very important bits of kit that will fix up here and will swivel. The hole here will connect with a connector rod to the bottom of this right hand pedal, the other side here down to here, that when one pedal moves forward, the other one will have to move backwards, and there's one scissor for this side and one for the pilot's side. First job is to knock in some nylon bushes. On that side. Put in a tiny amount of grease. And then the bolt goes in from there. So now we're ready for some connector rods. The connector rods, 4 of them, are made of a male end and a female end. They just screw together like that. Tee that up pretty much tight because there's not much distance for these to go between the pedal and the scissor. So that goes to there, and then the female bit will fit on here, but on the inside, and then the male on there. Okay, that'll need tightening up, but that's 1 down, 3 to go. Okay, so riser. It's a very simple piece of engineering, but look at that. One forward, one back. Superb. Now, all the kit's on the aircraft, but it's got to be connected up to the bits it controls. I need some control cables. Yes, even the control cables come in their little packages, E14 card 4F and E14 card 3F. Which one shall I start with? 3F. 3 cables down, 1 to go. It's the last, or the second one of the collective cables. It just slots through there. This is very like putting the brake cables on your bike when you're about 10, but of course this is a big boy's toy, so they're bigger cables. And then through into the control T, and some nuts on the end of there. Now these nuts will be changed for self-locking nuts later when we set it up, but for now that's cool. Right, to the other end. So that pops up there, like so. Just feed that in, put on the lock washer and a lock nut. Now the reason that this has 2 cables for each of these controls is, one, because that's a safety measure, obviously, because if one snaps you've still got some control, but also because when these are tensioned they will be tensioned against each other, and that will then move this, which is a rod end on a control T, which fits on the top of there like so. Just drop that down and put the lock nuts on, and it will move it into the perfect position to fit in this clevis. And then the job, as they say, is a good one. 39 quid, steel toe cap's a bargain, no VAT. Shall we see if it works? Here we go. We have got, I click, look at that, here's the collective. And yes, it's all working. That's it, my aviation chums. The control systems are in. Join me next time when I'll be putting in the engine. Do you think this thing will shake when it takes off? Should be more like this, you think?